All right, so this is the second day of 5.5. We are going to be talking about compositions of functions. So the first thing we're going to look at is a composition of functions is when you plug one function in as the variable of another. So we have a little picture here. If f of x is cookies and g of x is ice cream, if I were to plug ice cream into cookies, we would have an ice cream sandwich. But if I were to plug cookies into ice cream, we would get something like chocolate chip cookie dough. We write compositions like this. We have f of x normally, but inside of that, instead of x, we have g of x. So this is f of g of x. Sometimes they write it with this little dot here, a little O, all right? Or g of f of x means I would be plugging f of x in as the variable into g. So if I start with given all these things, and they want us to find f of g of 3. So I'm going to start saying, well, g of 3 is 2. So if I want to find f of g of 3, that really means I'm doing f of the equivalent to g of 3, which was 2. And if I look up here, f of 2 equals 7. So that would be my answer, just 7. So you go ahead and try this one. You could pause it, and then you can check your answer. All right, so you notice here, our answer would be 5. All right, so sometimes we're going to do it when there are just values, and sometimes we're actually going to do it when we have equations. So if I want to find f of g of x, that means I'm taking f of x as my function. So that means it's 3 times x. And I'm putting in place of x the entirety of g of x. So now I can distribute as I need to. We would have 6x plus 15, and that would be my answer. Whereas if I wanted g of f of x, I would start with g of x as my equation, 2x plus 5. Notice I'm putting a big chunk of parentheses where the x should be, because inside of that is where I'm going to put f of x. So now I'm only multiplying the 2 by 3x, and that would be my answer. So notice it's different. F of g of x was different than g of f of x. All right, let's look at another one. So again, f of g of x, I'm starting with f of x, which is x squared. I plug in g to that, which was x plus 7. So now I'm doing x plus 7 squared, which is the same as x plus 7 times x plus 7, or a final answer of x squared plus 14x plus 49. Whereas if I wanted to do g of f of x was x plus 7, and put f inside the parentheses, which means my final answer would just be x squared plus 7. There was no math to do. You go ahead and try this one. You can pause it and check your answer. All right, so if we do f of g of x, we get negative 4x plus 2. And if I do g of f of x, I get negative 4x minus 2. All right, we have one more problem to try. Same thing we're going to do, f of g of x. So I'm going to start with f of x. Let's ignore that bell. So it's 2x plus 8, so 2 parentheses plus 8. And let's plug g of x inside there. So that's 1/2 x minus 4 that goes in. So when I distribute here, 2 times 1/2 x is just x. 2 times negative 4 is negative 8. And then I bring down the plus 8. So these cancel, we get just x. For the other one, g of f of x, I'm going to start with g of x. So 1/2, big parentheses for x, minus 4. And let's plug f inside. And again, I'll distribute the 1/2. So half of 2x is x. Half of 8 is 4. Bring down the minus 4. These cancel. I'm left with just x. When we get to our next section, we'll talk about what happens if when we do f of g of x and g of f of x, we get back to x. But for now, it just works out that way. And that is compositions of functions.